Chapter 6.3, use similar polygons. All right, so the definition of similar in the case of polygons, which is anything with more than 3 sides or more, the angles are congruent and the sides are proportional. Okay, so we'll go over that in a minute. So real quick, just looking at their definition, the corresponding angles are congruent and the corresponding side lengths are proportional. All right, so here we have 2 similar polygons. This squiggly line here, just for your information, that line means similar. Okay, or you can say similar to. Now notice that one polygon is just a bigger or smaller version of the other one. All right, and based on this statement here, we can see which angles are congruent. Okay, if we match corresponding angles or just corresponding letters, we can go with the first letter in each one. So angle A matches angle E. All right, we can say angle A is congruent to angle E. And then if you go with the second letter, angle B matches angle F. So you just say angle B is congruent to angle F. All right, you can keep going, of course, with the third and fourth letters. For the third letter, angle C matches angle G. So you write angle C is congruent to angle G. And the last or fourth, D and H. Angle D is congruent to angle H. Okay, so now we're going to do the sides. Now, the angles are congruent, but the sides are in proportion. All right, so since ABCD is written first, I'm going to use that in the numerator, and then EFGH in the denominator. All right, so the sides are in proportion. They are not congruent. So if we take the first 2 letters, AB and EF, we can write one over the other. So I'm going to write AB over EF. And then I'll take the next 2, and that would be BC over FG. Okay, and then I can take the next 2, CD over GH. And then finally, first and last, AD and EH. AD over EH. So see, the side lengths are not equal. They're in proportion with each other. This fraction right here was letter numbers 1 and 2. This one right here was 2 and 3. This one right here was 3 and 4. And this one right here was first and last, or 1 and 4. Okay? You can't connect them any other way. You can't connect the first letter and the third letter, because that's not a side length, that's a diagonal. Okay, example 1 in the diagram, triangle RST is similar to triangle XYZ. Part A, list all pairs of congruent angles. Okay, please do that first, at least mentally. All right, so it's pretty straightforward. Look at the first letter in each one, you have R and X. So angle R is congruent to angle X. Second letter, S and Y. So angle S is congruent to angle Y. Third letter, T and Z. So angle T is congruent to angle Z. All right, so here's the triangles, and those are the angles that are congruent based on the statement. All right, let's do B and C at the same time. B is to check that the ratios of the side lengths are equal, and C is to write the ratios of the side lengths in a statement of proportionality. So I suggest you do C first and then B. Okay, and in order to write the ratios, do it the same way we did in the previous exercise. So let's see the diagram. Okay, so here's the statement. I just recopied it. Please use that to write the ratio and proportion for the side lengths, please. All right, for the first and second letters, since RST is written first, I'm going to use the ones for RST in all of the numerators. Since XYZ is written second, I am going to use XYZ for the denominators. All right, first and second letters, we have RS. First and second letters, we have XY. Second and third, ST and YZ. Finally, first and third, or first and last, we have RT and XZ. All right, so that's the proportionality of the sides. Okay, now let's go to B and check that the ratios of the corresponding side lengths are equal. Okay, so all we have to do is plug in the side lengths for these fractions. You can reduce the fraction or use the calculator to make sure they're all equal. So please plug in the actual numbers here and see what you get. Okay, RS is this one right here. That's 20. And XY is this one right here. That's 12. ST is this one right here. That's 30. And YZ is this one right here. That's 18. Finally, RT is this one right here. 25. And XZ is this one right here. That's 15. Okay. You can use the calculator and just get a decimal, or you can reduce fractions. So let's see. 20 and 12, these are both divisible by 4. 20 divided by 4 is 5. 12 divided by 4 is 3. 30 and 18, both divisible by 6. 30 divided by 6 is 5. 18 divided by 6 is 3. These are both divisible by 5. 25 divided by 5. And 15 divided by 5. And it checks out. So all the proportions are equal or equivalent. Okay, if two polygons are similar, then the ratio of the lengths of two corresponding sides is called the scale factor. In example 1, the common ratio of 5/3 is the scale factor of RST to XYZ. Okay, we did that already, and we got 5/3 for each one. So the ratio of the side lengths is basically the scale factor. All right, generally speaking, the one that's written first is going to be the numerator, and the one that's written second is going to be the denominator. Example 2, determine whether the polygons are similar. If they are, write a similarity statement and find the scale factor of ZYXW to FGHJ. All right, first let's check the angles. We have F matches Z, okay, because they both have one mark. We have H matches X because they both have 2 marks. G matches Y because they both have 3. And then right angle matches right angle, so J matches W. All right. So let's see. We're supposed to, when you name a polygon, you're supposed to go in order. Okay, you can start anywhere and go around in either direction. So I'm thinking F, J, H, G. Okay, F, J, H, G is similar to, and you do this one the same way, Z, W, X, Y. Okay, Z, W, X, Y. So when you do that, you want to make sure the angles match. Okay, so you see F matches Z, you see J matches W, and so on. All right, so we did the angles. Now we have to do the sides. All right, so we need 4 fractions here. All right, we're going to do 1, 2, 3, 4. All right, the first fraction is going to be letters 1 and 2, and then 2 and 3, and then 3 and 4, and then 1 and 4. Okay, please write the letters and then start plugging in the numbers. See if you get the fractions equal. All right, first 2 is going to be FJ matches ZW. Okay, FJ matches ZW. Second and third, JHWX. Third and fourth, HGXY. And then first and last, FGZY. Okay, and now we just have to plug in the numbers and make sure the fractions are equivalent. So let's see. FJ and ZW. FJ is 16, ZW is 20. So that's going to be 16 over 20. JH and WX, 12 over 15. HG and XY. HG and XY, that's going to be 24 over 30. And finally, FG and ZY, 20 over 25. Okay, you can use the calculator or just reduce. So I'm going to reduce. All right, 16 divided by 4 is 4. 20 divided by 4 is 5. These are both divisible by 3. 12 divided by 3 is 4. 5 divided by 3 is 5. Both divisible by 6. 24 divided by 6 is 4. 30 divided by 6 is 5. Both divisible by 5. 20 divided by 5 is 4. 25 divided by 5 is 5. So we got 4/5 for each one. It checks out. They are definitely similar. And this statement that we wrote at the beginning is the similarity statement. Now they want us to find the scale factor of ZYXW to FGHJ. Okay, let's see. ZYXW over FGHJ. All right. So as you can see in the one I did, I put FGHJ in the numerator, and I had ZYXW in the denominator. Okay, so basically I just have to take the reciprocal. So instead of 4/5, I just take the reciprocal, and it's going to be 5/4. All right, so that's it. The scale factor, let me see, the scale factor is basically the same as the ratio of the side lengths. So that's the scale factor. You just take one of the ratios of the side lengths, but make sure you have the correct numerator and denominator. Example 3 in the diagram, DEF is similar to MNP. Find the value of X. Okay. So what I would do here is just write the proportionality statements for the side lengths first. All right, so we're going to have the three fractions. First and second, DE matches MN. Second and third, EF matches NP. And then first and last, DF, MP. Okay. Now you don't have to use all three. You could use any two. But you do have to use the one with X because we're solving for X. All right. So let's see. X is right here. That's side length EF. So I'm going to use this one here. EF is going to be X. And NP is this one here. That's 20. Now I can use either one of these two. All right, it doesn't matter. So DF is 12. So in place of DF, I write 12. And MP is 16. All right, so now we're in business. Okay, cross multiply. Top times bottom is going to be X times 16. Bottom times top is going to be 20 times 12. And the opposite of times 16 is divided by 16. And that cancels. You can use the calculator, but let's see. Divided by 4, this is 3. Divided by 4, this is 4. 20 divided by 4 is 5. And then 5 times 3 is 15. All right, if you did the calculator, just do 20 times 12 divided by 16. All right, please pause and try this one. ABCD, similar to QRST. Let's take a look. All right, so first up, see if you can find the scale factor. QRST in the numerator, ABCD in the denominator. All right, so here's the similarity statement. Here is the fraction setup. You only have to do one pair of side lengths or one fraction to find this scale factor. So please try it. All right, the simplest way, I would just choose the first two letters. So AB, and that would go on the bottom. And QR would go on the top. Okay, see, I followed what they gave us. So QR is 6, and AB is 12. Okay, 6 over 12 is the same as 1/2. So that right there is the scale factor. Now, for number 3, they want us to find the value of x. So you don't have to do all 4 fractions because we already have the scale factor equals 1/2. So you just use the one with x and make another fraction, set it equal to 1/2, please. All right, so we said QRST over ABCD, that's going to be 1/2. And we just need to use the side length with x. So we're going to take x, okay, and x is in this one, ABCD. So ABCD is in the denominator, and BC is the second and third letter. So we need the second and third letter here. That's RS. So RS is this one right here. That's a 4. All right, and now we're in business. If you cross multiply, 1 times x equals 2 times 4. And 1 times x is just x. 2 times 4 is just 8. All right. Some of you, I'm sure you could do it in your head because we said at the beginning this was half. So if this side is half, then this side is going to be 2 times bigger, right? It's just going to be times 2. So if you took the 4, multiplied it by 2, and that's an 8. The only problem is sometimes they might not be oriented the same way. Like this one could be upside down versus this one, in which case you're going to have to use a statement. Okay, obviously you can see 12 is 2 times bigger than 6, so this would be 8, 2 times bigger than 4. But if this were upside down, you would have to use the statement. Okay, continuing with chapter 6.3, the ratios of lengths in similar polygons is the same as the scale factor. So theorem 6.1 shows this is true for perimeters of polygons. Let's take a look. Okay, if 2 polygons are similar, then the ratio of their perimeters is equal to the ratios of their corresponding side lengths. Okay, so here we have 2 4-sided polygons. Okay, and these polygons are similar. That means the corresponding angles are congruent and the corresponding side lengths are proportional. So this right here is the similarity statement. Remember this squiggly line? That means similar to. So KLMN is similar to PQRS. Now, if we were to write out the ratio of the side lengths or the scale factor, which is the same thing, there's going to be 4 fractions, okay, because there's 4 sides. So I'm going to make 4 fractions. And we've done this already. Okay, you take the first 2 letters, KL, and you match it with the first 2 letters on the other one, PQ. Okay, and then you keep going. Letter number 2 and 3, we have LM. And 2 and 3, we have QR. Okay, 3 and 4, we have MN. 3 and 4, we have RS. And finally, first and last, we have KN. And first and last, we have PS. All right, so this is the ratio of the side lengths. The ratio of the sides, which is also called the scale factor. Okay? And now what this theorem says, the ratio for the perimeter is equal to the ratio of the side lengths. Now, how do you find perimeter? We know that perimeter is the distance around. So to find perimeter, we just add up the 4 side lengths. Okay? And it says the ratio of the perimeter is equal to the ratio of the side lengths. So we can keep this ratio that we have here and set it equal to the ratio of the perimeter. So for the perimeter, I'm just going to add up the side lengths. So I'm going to do KL plus LM plus MN plus KN. All right. And in the denominator, PQ plus QR and RS plus PS. Okay, so here we have the ratio of the sides. And then on this fraction, we have the ratio of perimeters. All right, so those are equal. Okay, example 4, a town is building a new swimming pool. An Olympic pool is rectangular with length 50 and width 25. The new pool will be similar, but only 40 meters long. Find the scale factor of the new pool to an Olympic pool. Okay, remember we said the scale factor equals the ratio of the sides. So let's start with that. We want the scale factor of the new pool to an Olympic pool. Okay, so I'm going to put the new pool in the numerator. Okay, so the new pool is in the numerator, and the Olympic pool, I'll abbreviate OLY, is in the denominator. And we're looking for the ratio of the sides, which is the scale factor. Now, for the Olympic pool, they said the length is 50 and the width is 25. But the new pool, they said 40 meters long, so I'm assuming long means length. Okay, so we don't have the width for the new pool, we just have the length. All right, and we said the new pool is in the numerator. So 40 meters is the length. All right, so for the new pool, I'm going to write 40 meters, and I will label this fraction length. All right, so the new pool, the length is 40. I won't even use the equal sign. I don't want to confuse you. All right, the length of the new pool is 40. And the length for the Olympic pool, they said the Olympic pool length is 50. So the length of the Olympic pool is 50. And that was in meters. Okay, so it's just 40 over 50. Meters over meters cancel. Divide the top and bottom by 10, you cancel to 0. And you just have 4/5. So that's your scale factor, 4/5. And that's with the new pool in the numerator. Follow-up question, find the perimeter of an Olympic pool and the new pool. Okay, remember we said before in the theorem, the ratio of the sides is going to be the same as the ratio of the perimeters. Okay, ratio of sides equals ratio of perimeters. Now, a minute ago, we put the new pool in the numerator. and we put the Olympic pool in the denominator. And we said that was equal to 4/5. So that's going to equal the ratio of the perimeters. All right. Now we need to find the perimeters. All right, for the new pool, we cannot find the perimeter just yet because they only gave us the length. Okay, they didn't give us the width of the new pool. So in the numerator, I'm going to put P for perimeter, and that's going to be the new pool. Now, the perimeter for the Olympic pool, that's going to be easy to find. Okay, for the Olympic pool, they said it's rectangular, and the length is 50, and the width is 25. So this is what it looks like right here. Now we know for a rectangle, the sides across from each other are congruent. If this one is 50, then that one is 50. If this one is 25, then that one is 25. So since perimeter is distance around, we can just add these 4 side lengths. Okay, alternatively, we can do 50 times 2 plus 25 times 2. Remember, for the perimeter of a rectangle, the perimeter is basically 2 times the length plus 2 times the width. All right, that's the perimeter for a rectangle. So that's what we're going to do in our fraction. All right, so we have a length of 50 and a width of 25. So it's going to be 2 times 50 plus 2 times 25. So right here, we're going to do 2 times 50 plus 2 times 25. Okay, so we have the perimeter of the new pool in the numerator. And the perimeter of the Olympic pool, this is going to be 100 plus 50. That's going to be a 150. Okay, so we have the perimeter of the Olympic pool now. And this fraction equals 4/5. So all you have to do is cross multiply. Okay, top times bottom. I'm going to do P times 5. So perimeter of the new pool times 5. And that's going to equal bottom times top, 150 times 4. Okay, solving for P, this is times 5. The opposite of times 5 is divided by 5. Cancels here. Let me see. 100 over 5 is 20. So this, 150 divided by 5, that's going to be a 30. And then 30 times 4 is going to be 120. So that equals the perimeter of the new pool. Okay, and for the Olympic pool, we found the perimeter right here. $150 is the perimeter of the Olympic pool. So that's it. Notice to find the perimeter of the new pool, we didn't even have to find the width. Okay, we were given the length. We didn't even have to find the width. We found the ratio of the sides and set it equal to the ratio of the perimeters. So last time we were given 2 5-sided figures. Okay, And they gave us the similarity statement. They wanted us to find the scale factor with FGHK in the numerator. So we did that last time. Okay, we put FGHK in the numerator, and we found the scale factor to be 3/2. Now what they want us to do is to find the perimeter of ABCDE. So we are going to do this problem right now. So we are going to use the scale factor, which is 3/2, and set that equal to the ratio of the perimeters. So let's do that. Okay, so the ratio of the scale factor is 3/2. And I'm going to set that equal to the ratio of the perimeters. Okay, so the perimeter of this one here, I'm just going to call it P with a lowercase f. If you want to write it out, you can write FGHJK. Okay, and the perimeter of the other one, I'm going to call that P and ABCDE. Okay, so see if you can finish this one. The perimeter of FGHJK is just adding the sides of this one right here. So you guys can do that part. And then this part here, you do the cross multiplication. So please finish that. All right, so we have 3/2. And the perimeter of this one here, we add side lengths. So we have 15, 9, 12, 15, and finally 18. And that is divided by the perimeter of ABCDE. All right, I'm just going to write P sub A. All right, we have 3/2. And adding this here, 15 plus 15 is 30. Plus 12, that's 42. Plus 9, that's 51. 61, 69. And that's divided by the perimeter of the one that starts with A. Okay, let me double check this on the calculator. Okay, 69 is correct. And of course, at this point, we are going to cross multiply. Okay, top times bottom is 3 times P sub A. Bottom times top is going to be 2 times 69. And since this is P times 3, the opposite is divided by 3. All right, cancels here. You can do the calculator or in your head. 69 divided by 3, let's see. 3 into 6 goes twice, and 3 into 9 goes 3 times. So 69 divided by 3 is 23. 2 times 23 is 46. So the perimeter of the one that starts with A is 46. So this perimeter, the bigger one, that was 69. So for this one here, the perimeter was 69. That was the easy part. And the other one, this one here, the perimeter was 46. So notice once again, we did not even need to find these missing side lengths here in order to find the perimeter. All right, this right here just says that any two congruent figures are also similar. Okay, their scale factor is just going to be 1 to 1. All right, so if you have two congruent triangles, the scale factor is just going to be 1 to 1, and the triangles are also similar. So congruent triangles are also similar. That's all they're saying. Okay, here it says, if two polygons are similar, then the ratio of any two corresponding lengths in the polygon is equal to the scale factor of the similar polygons. Okay, by the way, a triangle is considered a polygon. So example 5 in the diagram, triangle TPR is similar to triangle XPZ. Find the length of the altitude PS. Let's take a look. All right, so they give us one pair of side lengths here, and then they give us one altitude, and we're looking to find the length of this altitude right here. I'm just going to call it X. Now, what we're going to do for this, since we're trying to find the altitude, we know that the ratio of the sides is going to equal the ratio of the altitudes. All right, that was the whole point of the theorem. They said if the polygons are similar, then the ratio of any two corresponding lengths in the polygon is equal to the scale factor, and the scale factor is the same as the ratio of the sides. So let's find the ratio of the sides first. Okay, I'm going to put TPR in the numerator, and I'll put XPZ in the denominator. All right, so let's look at the side length for TPR first. All right, this triangle here is TPR. This side length right here is just going to be 6 plus 6. And now for XPZ. XPZ is this one right here. This side length is just going to be 8 plus 8. Okay, 6 plus 6 is 12. 8 plus 8 is 16. We could leave it like that, but I would prefer to reduce, but you don't have to. Okay, these are both even, these are both divisible by 4. 12 divided by 4 is 3. 16 divided by 4 is 4. And the ratio of the altitudes, okay, the altitude for TPR, this one is TPR. Here is the altitude right here. All right, notice it's perpendicular to the side. That altitude is X. Okay, and the altitude for XPZ, XPZ is this triangle. The altitude right here is 20. All right, so if you notice, the ratio of the sides is basically this fraction here once we reduced it. And the ratio of the altitudes is this fraction right here. So we set the sides equal to the altitudes, that's all. And now once you cross multiply, top times bottom is 3 times 20. And that equals bottom times top, which is 4 times x. Solving for x, the opposite of times 4 is divided by 4. It cancels here. 20 divided by 4 is just 5. And 3 times 5 is 15. So x equals 15. Now, the only thing I want to make sure of is if I used corresponding sides when I did the ratio. Let's see. So this side right here, that goes from T to R. So that's TR. And this side right here goes from X to Z. So that's XZ. All right, so let's make sure that TR matches XZ. All right, TR is the first and last letters, and XZ is the first and last letters. Okay, see, I used the statement right here. So just make sure that you're using corresponding side lengths. You can't always just look at the drawing. Okay, last one. Please try number 7 in the diagram. JKL is similar to EFG. Find the length of the median, KM. Okay, so you want to use this similarity statement here. And they gave you this median here is 35. This median right here is what we're looking to find. So I'm going to call that X. Okay, and this side length here, this is 48. This is 48. If this is 40, then this is 40. So please complete this problem. Find the ratio of the side lengths and make that equal to the ratio of the medians. Okay, we know that the ratio of the sides equals the ratio of the medians. All right, so I'm going to put JKL in the numerator. And I'm going to put EFG in the denominator. All right, we were only given one side on each one. So for JKL, that's this one. The side length is going to be 48 plus 48. And for EFG, the side length is going to be 40 plus 40. Okay, 48 and 48 are 96. 40 plus 40 is 80. All right, you can reduce this, but I'm just going to leave it just to prove to you you don't need to reduce it, because once you cross multiply, it's not going to matter. All right, and now for the ratio of the medians, JKL is the numerator, so that's this one. The median right here, see, it goes to the midpoint. That's X. And the median for EFG, that's this one right here. See, it goes to the midpoint. That's 35. All right, so that is it for the fractional part. We're going to cross multiply. 96 times 35. Let me see. I'll do it right here. 96 times 35 is going to equal bottom times top, so that's 80 times X. Okay, see, if we had reduced this, we would have smaller numbers, but no big deal. So the opposite of X times 80 is divided by 80. I'm going to do that to both sides. Cancels here. And now let's see, you can do it with a calculator or you can do it by hand. 35 divided by 5 is 7. 80 divided by 5 is 16. And let me see, 16 divided by 8 is 2. And 8 into 96 is going to be 12. 12 divided by 2 is 6. And 6 times 7 is just 42. So X equals 42. Let me double check on the calculator. We had 96 times 35 divided by 80. If I just do that real quick. 96 times 35 divided by 80. I get 42. So that's it. Okay, so like I said, you can reduce here or you can just leave it. You can do this on the calculator or by hand. Okay, and there were no units. So that's it, no units.